Hello and welcome back. Today we are looking at 2.3, which is problem solving using inequalities. So we're going to do the same exact thing that we did in chapter 1, only this time we're going to look at inequalities. So our first problem says a toll booth charges 75 cents for each time you pass through. If you purchase a special sticker though for $6.25, then the toll is only 25 cents each time that you pass through. So it says at least how many trips through a tunnel are needed before the sticker costs less than paying for each trip separately. So notice how it specifically states cost less. So this is not going to be an or equal to because we want to know when it is going to be less. Okay, so let's write our equations, right? Our first circumstance, right, we're going to pay $6.25 straight up front. And then to that, we're going to add 25 cents for each trip. So we'll call T our trips. Okay. The second way that we could do it is just to simply pay 75 cents per trip. So we're trying to determine when will this side, our 6.25 plus 0.25t, be less than just paying 75 cents per trip. So to do this, we're just going to simply solve for t. So we have to follow all the same rules that we've been following for solving inequalities. So we're going to subtract 0.25t, and you get 6.25 is less than 0.5t. And now we need to solve for t. So to get rid of that multiplication by 0.5, we have to divide by 0.5. So we're just going to divide both sides by 0.5. Okay, and we get that 12.5 is less than t. So remember, if we want to write that the other way, right, we just read it the opposite way. T is greater than 12.5. So we're looking for the first trip that makes it cheaper. So if you had 12.5, realistically, right, is our break-even point. So it has to be greater than that, and the first one above that would be 13 trips. Okay, for number 2, it says the length of the rectangle is 5 inches more than 3 times its width. Find the smallest possible width if the perimeter is at least 90 inches. So the first thing I always do on these is draw a picture. So let's draw our picture. Right, we have this width, and then we have that the length is 5 more, so plus 5, than 3 times our width. Okay, and then we have to remember that to find our perimeter, right, we're adding up all the sides, or we're just simply doing 2 times 3w plus 5 plus w. Okay, and then it says find the smallest possible width if the parameter is at least 90 inches. So we want this to be greater than or equal to because of the word at least here, and then our 90 inches. So we can distribute this through, well actually before we even do that, let's just go ahead and add this 5 in, which I forgot to write. So 5w, or 3w plus 5 plus w. So now I'm going to combine like terms in my parentheses first. So this is going to be 2 times 4w plus 5 is greater than or equal to 90. So now I can distribute this 2. So 2 times 4 is 8w, 2 times 5 would be plus 10, is greater than or equal to 90. So just like before, we're going to solve it. So we're going to subtract 10 from both sides. We're trying to get our w by itself. So 8w has to be greater than or equal to 80. And then we need to divide both sides by 8. So w has to be greater than or equal to 10. So what's the smallest possible? Well, 10 then would be the smallest possible, so that's just 10 inches. Okay, on to the next one. We have the length of the sides of an isosceles triangle are integers. The base is 1/4 as long as each leg. What are the possible lengths of the legs of the perimeter? Has to fall between 10 and 30 units. So again, I like to draw this. If you remember an isosceles triangle, right, we have our 2 that have to be the same, which are our legs, and then our base. And it says that our base is 1/4 as long as each leg. So 1/4 x. Okay, so at this point we have x, x, and 1/4 x. Now, one of the keys when we get going a little bit further is the fact that all the sides have to be integers, but we'll come back to that here in a minute. So this perimeter has to fall between 10 and 30. So x plus 1/4 x, right, has to fall between 10 and 30. So now you can do whatever you want as far as to work with the fraction or to get rid of the fraction. I'm just going to work with the fraction. So x plus x, right, would give me 2x, and then 1/4 x would give me 2 and 1/4 x. But really, we want to put that into an improper fraction. So 2 times 4 is 8, plus 1 is 9. So this is 9/4 x, and then we have, right, that has to be less than 30, but greater than 10. So now I need to multiply each part of this by 4/9. So if I multiply all three, right, because whatever you do to one part, you have to do to all three parts. And when you do that, you're going to get 40/9 is less than x, which is less than 120/9. Now, this is one of the few times where I'm going to tell you it's okay if you want to turn this into a decimal, because in the end we're only looking for the integers anyway. So if our decimals get rounded a little bit, we'll still be okay. So that gives us 4.4 repeating is less than x, which is less than 13.3 repeating. Okay, so now, like realistically, right, okay, well, what are the integers that fall between 14.4 and 13.3, right? That would be 5, 6, 7, 8, 9, 10, 11, 12, and 13. But now we have to go back to the fact that it says that all sides of the triangle are integers. So since we have this 1/4 x here, the only ones that work are multiples of 4. So that means 5 doesn't work, 6 doesn't work, 7 doesn't work, 8 does, 9 doesn't, 10 doesn't, 11 doesn't, 12 is a multiple of 4, that'll work, and 13's not. So it says what are the possible lengths of the legs? Your possible lengths would be 8 units, okay, and 12 units. That off. All right, on number 4, it says find all sets of 4 consecutive integers whose sums should be r between 10 and 20, or the 4 consecutive integers whose sum is between. Oh, I guess that does work. All right, so that gives us, right, 4 consecutive integers. So that's x, x plus 1, x plus 2, and x plus 3, right? Because integers, right, are those counting numbers and their opposites, or your whole numbers and their opposites. So we want this to fall between 10 and 20. So we're going to have 10 is less than x plus 1 plus x plus 2 plus x plus 3, which is less than 20. So now we have to combine like terms. So we have 1, 2, 3, 4 x's. And then 1 plus 2 is 3 plus 3 is 6. And then again, remember, whatever we do to one part, we have to do to all parts. So to get rid of this plus 6, I have to subtract 6 from every part. So that gives me that 4 is less than 4x, which is just less than 14. Now to get this x by itself, we have to divide by 4. So if we do that, 4 divided by 4 is 1, is less than x, which is less than 14 divided by 4 is going to be 3 and 1/2 is what's left. Okay, so again, if you left that as a decimal, it would work. Okay, so we're looking at the consecutive integers. So what are the integers, right, that are greater than 1 but less than 3? So it'd be 2 and 3, right, would be the possibilities for our x. So if we want the sets, right, if the first one is x, then the second one's x plus 1. So 3, 4, and 5, and then 3, 4, 5, and 6, right? Because we have to add to x to get our other 3 terms. So we were just solving for x, which is the first in the sequence, and then you have to write out the rest of the sequence. So find all sets of 3 consecutive even integers whose sum is between 10 and 20. So now we have 3 consecutive evens, so x, x plus 2, and x plus 4, because those are our 3 even integers in a row. So 10 has to be less than x plus 2 plus x plus 4, which has to be less than 20. So 10 is less than 3x plus 6, which is less than 20. Same thing as before, subtract 6. You get 4 is less than 3x, which is less than 14. Divide them all by 3. Okay, and this would be 1 1/3 is less than x, which is less than 4 2/3. So our potentials for x, right, would be, because they have to be integers and even integers. Well, you would have 2, 3, and 4, but 3 is not even, right? It's odd, so we can't start off one of ours with that number. So then we have 2, 4, and 6, and 4, 6, and 8. Remember, we're only solving for the first one. Okay, for number 6, we have find all sets of 3 consecutive odd integers sum who's between 10 and 20. So it's the same exact thing, right? Because odd integers are also just x, x plus 2, and x plus 4. Because, right, the first one is odd, which is what makes it 2 more odd and 4 more odd. So it's going to literally be the same exact equation. Okay, it's just going to be different when we get to the bottom. So we know that this is the same as this one was up here. So when we solve this down, this is going to be 1 1/3 x, or sorry, 1 1/3 is less than x, which is less than 4 2/3. So again, we'd have that 2, 3, and 4 options. But this time, right, we're looking for odd integers. And so we're looking for odd integers, the 2 and the 5. 4 cancel each other out, sorry. So that means you would have 3, 5, and 7 left. And then last but not least is number 7. It says Paige's test scores were 85, 95, 97, and 79. What would she have to score on her next test to raise her class or her overall test average to an A, which means a 93 and above? So if we think about that, we have the 4 that we're given so far. Right? And then we're going to add a 5th. That's our x. An average means you add them all together and divide by the total number of tests. So there would be 5 total tests. Right? And this has to be greater than or equal to that 93. Right? It's or equal to because it says an A equals 93 and above. So if we add these 85, 95, 97, and 79 together, that gives us 356 plus x over 5 is greater than or equal to 93. So now to get rid of this divided by 5, I can multiply both sides of my equation by 5. Those 5's cancel each other out, and I'm just left with 356 plus x on the left-hand side. And on the right-hand side, that would be 465. So then if I subtract 356 from both sides to solve for x, we get x is greater than or equal to 109. What? That's a problem, right? So if she needs to get 109 on her next test, right, that's not really going to happen. Okay, so she can't raise it that high. So it's impossible, right? So mathematically it's possible, but it's impossible due to the situation, right? So due to test, right? You could only get 100% on a test. So due to, I guess I should have said possible test scores. Possible test scores. There we go. Hopefully that was helpful, and good luck on your homework.